Okay, right, so this is equal to 1 over 17. Sorry, I got sloppy there on that. But so remember, the key is defining that number that I need to plug into right here to get us negative 11 out. All right, and then all we have to do is just take the derivative, plug that number in, and take the reciprocal of whatever this number is. Okay. All right, one more example on this. Let's say we have f of x is equal to x cubed minus 4 over x, and we want to find we want to find the derivative of the inverse, and evaluate it at 6. Alright, so in other words, what number do I need to plug into this thing in order to get 6 out? So I go through and I plug 0. Okay, can't use 0. Plug 1 in. It's not going to be 1. Plug 2 in. 2 cubed is 8. 2 down here. 2 goes into 4 2 times, and 8 minus 2 is 6. So x is equal to 2. Alright, good. So now what I'm going to do is take the derivative of this up here. So I'm going to actually rewrite this, bringing this x to the top, and makes it negative 1. It's a whole lot easier than using the quotient rule. Okay. So we take the derivative, we have 3x squared plus 4x to the negative 2. So hopefully you're up on taking derivatives, so I don't have to go step by step on that. Now what we're going to do is plug 2 into this, so f prime of 2 is equal to 3 times 2 squared plus, now this x to the negative 2 needs to go back down into the denominator, so this becomes 2 squared down here. And so we end up with f prime of 2 equals 13. Alright, this should equal 13. Let's see, 2 squared is 4. That's going to be 3 times 4 is 12. That's 1, and 12 plus 1 is 13. So all we need to do now is the derivative at 6. So we know that it's the reciprocal of 13, which is going to be 1 over 13. That easy. Okay. Now let me just say something here real quick. I remember when I was first doing these problems, I'm thinking, well, here's an equation right here. Why don't we just solve for x in this problem? Okay, well, sometimes it's pretty difficult to actually solve for x in these equations, so that's the reason we have to do this trial and error thing. In other words, plug a number in and see what it's equal to. So normally they give you a number out here, okay, that's where you're just going to have to plug a few numbers in to actually figure out what this, try to get this to match 6. All right, and also, back in college algebra or high school algebra or whatever, knowing how to find the actual inverse of this function. Remember, you'd put x here, and then y is here, and you would solve for y. Well, if you could do that, and then take the derivative and plug 6 in, well, that would be great too. But that's kind of difficult. Okay, and really the whole idea here is knowing the relationship between the derivative of the function and the derivative of its inverse, and its relationship is they're just reciprocals of each other. They're just reciprocals. Their derivatives are reciprocals of each other here at a point. Okay, so I think that's what we're usually trying to just get at. Okay, well, I think that's it for examples. Hopefully you caught on, and that helps you out on how to find the derivative of an inverse at a point. All right.